Okay, so
that's 10. That's 3, 4, 5.
yep. Okay, so how many is there? So there's 12 on each side.
96.
Yep. Yeah, Alexandra. Is this right? Yeah, hold on just a second. Let me check.
12, but you have to add one more. Oh no. Okay, let's get rid of this. You did 2 times 6 was 12. So you put a 2 here and carry 1. Now you're on to the next. 2 times 6 is what? But then you have to add 1 there. Carry. What's 12 plus 1? 13. Yeah. Okay. Now you take care of this 6, now you gotta go to 4. Yep. Yeah, right. 2 times 4 is 8. 39. Right. Now you're ready to add. If you were to write this as a decimal, put it on like these guys. Okay. All right, so you want to fix it over here? Let's see if you did. Let's fix it right here then. See, here was the problem. Let's fix the problem. It doesn't have to end out equal. I want you to fix this problem. Let's erase that one. Put it here, hang on, so tell this one. And then you're going to erase the 9. Erase that 9. Because that's okay, wait. What happened? All of it, right? Let's just start this whole thing over here. I got you.
Exactly. He knew. I'm just not explaining it well enough. All right. That's exactly right. So what should this in about? How quickly are we going? We're going 51 nautical miles per hour. You don't have to get into that right now. But I'll be seeing Echo Charlie appear here, and then I'm going to see.
Pretty soon that DC is going to go EC, and it's going to go to low.
And the 9456 will still stay as long as I'm going relatively north. And then that 9937 is going to become 0. It's going to zero out because I'm on the next map. Okay, all right, so if you get a call on the radio and some guy needs your help, all right, he gives you a grid of where he is. You can punch that grid in. You see that? You see the little dial? It looks like a phone down there. There's a whole method by which you type in the next grid, and then your helicopter will tell you where to go. All right, so we typed in a grid, and see where underneath the 51 right up here, see where it says DIR? That DIR means direct waypoint, so we're headed directly to another point that we've plugged in. All right, and then what's the next line say? Oh, yeah, you guys might not be able to see it too well.
Well, hers is
38.5 kilometers. That's how far we are away from our next target. Okay? And then, what's it say beneath that? Go ahead.
13.6 ETE.
ETE means estimated time en route, and that's in minutes. So 13.6 minutes to go 38.5 kilometers. All right, keep going down, next point, start route. Okay, now who can tell, right there, you see where that is? It says 280 pph. All right, when your helicopter runs out of gas, it's not like your car running out of gas. It's not like you just pull over and then you walk to your gas
You're
station.
dead meat, right?
Yeah, you'll fall out of the sky, so that's never good. So an extremely important thing you have to do constantly is make sure you have enough fuel to get where you're going. All right, so we measure fuel a little bit differently. Instead of in gallons, we measure it in pounds, because we're all calculating how much weight, how much we weigh, because we don't want to put too much load on the rotor system. So we just measure gas in pounds. So that 280 is how many pounds per hour we're burning. Does that make sense? So we're burning 280 pounds of fuel an hour.
That would change all the time depending on, but he took a picture of the cockpit at that
Yeah,
time.
I'm just trying to take as much application off of this one picture as we can. So that 1.7 hours tells you how much time until you're out of gas. Okay? So, what does that information give me? What do those two data points let me do? What can I figure
What
out?
do you have here? What do you have?
280 pounds per hour.
Is it like that, okay?
And 1.7 hours until burnout. What do you think?
Says that you still have 280 pounds. More than 280 pounds.
That means exactly right. Does everyone hear what he just said? One piece of information, you know you have more than 280 pounds because you can fly for more than an hour, right? And if you're burning 280 pounds per hour, you have more than that. So, if I asked you, how many pounds of fuel do I have in the aircraft right now? Could you guys tell me?
What operation would you use and how would you figure it out? 280 pounds per hour you're burning, you got 1.7 hours left. You know what?
What would you do?
I'll multiply them.
Exactly. What do you think, approximately, just without having a calculator, just quick, because you know your boss is yelling at you over the radio, and he wants to know if you can get back right now because you're out longer than you're supposed to be, and you just need to quickly know about how much gas you have left in there. What do you think?
400.
Exactly. That's a great guess. About 400.
How'd you come up with that,
How'd you
by
get
the
it?
way?
Mainly, I just divided 280 in half.
And what'd you get? You do mental math is cool. What's the half of 180?
140.
Yeah, 140.
280, yeah.
And I knew it was larger, so I divided it by 5, and the actual one is 7. So I just
So,
So you pretty much just added those up, and you said it's just about 400
and a little more.
and a little bit more. So you
It's
have,
probably good to be conservative.
yeah, if you're a little
Make sure you have
conservative, that's
more
good.
gas than you think you have.
Excellent. Excellent.
So it might be more like 450 or something probably, but if you had a calculator you could do it, but mental math is cool.
Okay, here's another question. Remember that estimated time en route, 13.6 ETE? Okay, that's how long it's going to take me to get to my next point. Do I have enough gas to get there?
Like if he might have to go rescue somebody out there at 13.6.
But I don't want to crash, because if I crash, then they're going to have to rescue a lot more
Kilometers.
people. You know, and that's not doing anybody any good. But I want to help the guy who's out there. So do I have enough gas to get to the next point? Why do you say no?
it's because if it takes 13.6 hours.
It's minutes, sorry. That's minutes. Estimated time now is in
Oh.
minutes. 13.6, you're correct. If it was 13 hours, absolutely not. 13 minutes.
So yes, you will have enough.
So you would have enough. Okay, how much fuel do I need to get to my next point? In pounds. Here, let's get somebody else a shot.
Let's try some estimating. How much fuel are you going to use in 13.6 minutes if you are using 280 in 1 hour? You can turn your paper over and draw some pictures or something if you want to. Let's see, you got 13.6 minutes.
Just roughly.
1/4.
1/4. Exactly right. So it's about a quarter, right? 25%. All right? So if I'm burning 280 pounds per hour, what operation would you use to figure out?
Seven what?
70 pounds.
How'd you get that? Okay, so you said, basically, this was the operation actually, whether you know it or not. You were saying, oh, 1/4 of the hour. I'm taking 1/4 of the 280 pounds. Or that's the same as 280 divided up into 4 groups. 4 15-minute groups. Yeah. So it could be 280 divided by 4. And these are actually the same. Remember, not by 2. Yeah, it's like I have 280, you know. I'm going to divide it into 4 parts. Each one's going to be 70, right? 70. So 15 minutes, I'm going to use 70 pounds. Okay? You got it?
And in a half hour, how many pounds of fuel are you going to use?
Because you're going to have to turn around and come back, right?
Because you got to come back. So in a half hour, how much fuel do you use? You guys know?
Just in
140, exactly. What about 45 minutes? In 45 minutes, how much fuel do you burn? If this is 15 minutes, a quarter of an hour is 15 minutes. Half an hour is 30 minutes. 3/4 of an hour is 45 minutes, and you're burning 70 pounds every 15 minutes. So in 45 minutes, so 3 of these, how many pounds? Exactly right.
Good.
It's 210 exactly, but we're doing quick little calculations. So yeah, about 200 pounds.
And why are you doing quick calculations in the helicopter? And then we need to end. Why are you doing quick
me?
calculations? Why do you have to be able to do all this mental math and stuff?
Because everything's changing. You know, every time you move a stick, you put a control input, you're changing all these numbers. They're changing constantly. But these are it's just a broad idea of information, so you can make a quick decision. All right. Well, the whole point of this was to show you how important math is. While you're reading your little problems in the books that came just from somebody's head, and they're tools to help you learn this stuff and to explain it to you. But this is the real world application. You know, we do this on a regular basis every day, and it's a lot of fun. It's a lot of fun because you can help people. You can see what your capabilities are. So that's the whole reason I wanted to come in here today, just to kind of motivate you guys and to show you that there's a little bit more to it than some standard problems that you see in the textbook. There's real world stuff out there.
Those problems are practice for when you get to something like this. Really, can know what you're doing, you're confident with it, and you can stay alive. Actually, you can stay alive in that helicopter.
And that's a good thing.
And this is just one career that uses a lot of math.
I got a question.
Go ahead.
Have you ever got lost?
Have I ever got lost?
Yeah.
Of course not. Yeah, once or twice. Never in the helicopter, because you do a lot of planning ahead of time.
Oh, okay.
But sometimes you do have to go
I've gotten
find.
disoriented when you're in a steep bank and you're having to get around, and then you realize, wait, where's north again? Then you have to recage yourself.
And you have all this instrumentation to help you, right? Okay. Oh,
How many of their instruments malfunction?
Yes, good question. They do. That's why we have backups. You can't see the whole cockpit, but like, see, it says 51. That's how fast we're going. What does this gauge say? 51. 51. Yep. So there's a backup to everything. So if this fails, I can go off my manual.
this is called analog.
Analog and
And
digital.
digital, I don't know if you guys are aware of the difference. Analog is like, pointers going around and stuff like that.
And there's all for all this other data,
What's that?
altitude.
Right, like an
Right,
analog
an
clock.
analog clock has hands on it, right? The digital clock just has digits, otherwise known as numbers, right? Okay.
Cool. All right. Well,
All
I
right, we
appreciate you
should
guys listening to
probably-
me. Thanks a lot.
Well,
And,
thank you for coming in.